Submarines, the last line of deterrence of any nuclear country. Starting from First World War, submarines became essential part of naval warfare. During that time and up until 1950s, submarines mainly were diesel-electric. After advancements in nuclear technology, submarines started to use nuclear reactors for their long journeys. Nuclear-powered submarines are capable of traveling several months and tens of thousands of kilometers without ever surfacing. So what makes submarines so formidable and deadly? The main advantage of submarines is their stealthiness. But what makes them so stealthy? Why countries that can detect small aircrafts across thousands of kilometers have issues detecting huge nuclear submarines? The answer is fairly simple. Saline water is a great electrical conductor, which essentially means that it blocks all the radio signals. So this means that the radars that are used to detect aircrafts are practically useless against submarines. This is the reason why submarines themselves use VLF, very low frequency radio, for communication and have to come near the ocean surface to be able to receive and send signals on very low radio frequencies. These low frequencies have long waves and unusable for any kind of radar application. And these frequencies have very low data transfer rates. So for faster communications, they might have to deploy surface beacons. That is why current detection technologies rely mainly on sonars that use sound waves to detect submarines. Sound waves in the ocean are about 4 times faster than in the air. Sonars in turn are either active or passive. Active sonars behave much like radars, but use sound instead of radio signals. They send sound waves and listen to the echoes from the ocean. So when the sound reflects from a submarine surface, they can detect the submarine. Passive sonars don't emit any sounds themselves, but rather listen to the sounds of the oceans, trying to detect submarines, engines, or other related noise signatures. But current submarines are built with this in mind. They use so-called anechoic tiles to reduce their noise signature against active sonars. And modern submarines are designed in a way to reduce their engine motor's noise, to be at least less noisy than the ambient ocean, so to make detection by passive sonars difficult. Another technique is to use magnetic anomaly detectors. As submarines are big and mainly from steel, this technique relies on registering small magnetic fields changes in the ocean to detect submarine presence. However, modern submarines use demagnetization techniques to reduce detection by this method. Other techniques might use radiation signature detection from submarines' nuclear reactors activity, or trying to detect heat from the reactor or submarine itself. But again, in the context of the ocean, which essentially blocks radiation and infrared, these detectors are of limited effectiveness. Not only the ocean blocks RF signals, but also practically it's impenetrable by big chunk of electromagnetic spectrum. Infrared and visible light cannot penetrate the oceans in any meaningful way beyond 200 meters mark. So visual or infrared detection, even by using modern radars, again have low effectiveness. In general, modern navies, while deploying anti-submarine warfare, try to utilize all of the mentioned tools and sensors together to increase chances of detection. However, the vastness of the oceans and properties of saline water to block radio signals makes submarines a formidable force to reckon with.